This is going to be more of a mini video because I don't know why this camera has like 0 battery life. It's almost dead again. But we're going to talk about a law called the conservation of momentum. Conservation of momentum. What does that mean? It just means, right, just like energy, right? Conservation of energy said my initial energy is the same as my final energy. Conservation of momentum just means my initial momentum, P, is equal to my final momentum, P prime. So how can we do things that relate to conservation of momentum? Well, let's go back to the shopping cart. So let's say I have a shopping cart, right? Here's my shopping cart, and I'm sitting inside like an epic gamer, and I want to find, right? I want to find how fast the shopping cart is going to go if if the whole system starts at rest. The whole system starts at 0 meters per second, and I jump out of the shopping cart, and I'm moving at a constant 5 meters per second. Let's say maybe I'm 50 kilograms. So here is my initial state, and then my final state is where I jump out at 5 meters per second. This way, I want to find how my shopping cart is going to move, right? It's probably going to move backwards, right? Because if I'm moving forwards, the shopping cart is probably moving backwards somehow. But I want to calculate exactly how fast. So I said, maybe I'm 50 kilograms and the shopping cart is 25 kilograms. So how do I use this law? Well, I just have to calculate my initial momentum, right? Initial, this is the initial state, and this is the final state. My initial momentum is 0. I'm stationary, so I say my initial momentum is nm, right? No velocity means no momentum. What about my final? Well, my final momentum is going to be equal to the sum of all the momentums in the system, right? It doesn't matter because they're going in the same direction or along the same axis. This is very important. You can only sum them when they're going in the same axes, right? Either forward or backwards in a line. If I had 2 dimensions, right? If I was going up and the cart was moving to the left, then I can't just sum them. I have to use some Pythagorean theorem to do that, and we'll talk about that a little bit in the next video. Actually, we'll cover that in the next video, right? So they're going the same direction, so I can sum them. Okay? So my momentum, the momentum of me, is 5 times 50, so that's 250 Newton seconds, or Newton seconds. Oh, shoot. Right? And what is the momentum of the shopping cart? Well, the momentum of the shopping cart is the mass, right? M shopping cart times the velocity of the shopping cart final, which is equal, and this is 25 kilograms. We also know P prime is equal to P. So I can say, what I can do is I can write this as 0 Newton seconds, my P is equal to P prime. So that's 250 Newton seconds plus 25 kilograms times my final velocity of the shopping cart. So now I just do a bit of rearranging, and I find the final velocity of the shopping cart is equal to 250 Newton seconds divided by 25 kilograms, which is, negative 250, right? I moved it to this side, so I have to subtract, and I just rearranged the equation a bit, is equal to 10 meters per second, just by unit, or negative 10 meters per second. I jump, I move 5 meters per second. The shopping cart is going to have a momentum that counteracts my momentum. It's going to have the exact same momentum as me for the 2 momentums to add up to 0, right? So it has to move over this way twice as fast because it has half the mass. So it moves over on the left side, right? I said this is positive, so this has to be negative 10 meters per second. And there we go. That's how we use the law of conservation of momentum in order to find momentums of different systems. So the problems you're going to see on the AP test, if they come up with these problems at all, are going to be, they'll give us the initial, you'll have to calculate the initial momentum, or maybe the final momentum, and then they'll tell you, or you'll be able to find out the momentums of all objects except for one. And then you have to use the law of conservation of momentum to find the momentum of the other object, just by setting our initial momentum to equal our final momentum. We'll go over law of conservation of momentum problems in 2 dimensions in the next video, so don't worry if this is a little fast. This is just jump in to how we can apply these laws. Have fun studying. Bye.